All right, good morning, Saintsmen. We're going to be working today on lesson 3.4. We're going to discuss a different methodology for graphing. When we have the standard form of an equation, it looks like this. So we have discussed already the function form, which is very similar to slope-intercept. And the standard form is capital A, x, plus capital B, y, is equal to capital C, okay? Moreover, there's a couple exclusions here. It's that this is considered to be only way that we can actually have this is that A, B, and C are all real numbers, and both A and B cannot be zero. In other words, there's no equation if we actually have 0 as a coefficient for A and B. Consider what happens when we do that. What winds up happening is that, for example, if A were to be equal to 0, we'd have capital BY equal to C, okay? And if we solve for that, y would be equal to C over B. When you do that, you can actually graph that, okay? It winds up being, ironically, a horizontal line. So let's take a look. Go ahead and sketch my coordinate plane. Of course, I don't need you guys to do more than your coordinate plane like this. So I don't need it to be on graph paper or anything. This is, you guys can see I kind of shortcut my my quadrants here. So I'm really kind of focusing on that first quadrant. And here, let's say that y is equal to 3, okay? What that winds up being is, even though we see y, we think vertical axis, right? Instead of y being that vertical axis right now, it winds up creating a horizontal line. Watch this. We're gonna go through y, 1, 2, 3 on the y-axis. We'll put a point through there, but we wind up putting a line directly through that, but that's not gonna touch the x-axis, so it winds up being parallel, and it's a horizontal line. Versus the following. Let's say that we have another coordinate plane here, right? And let's say we have x is equal to 3. So x equal to 3 is going to wind up being a vertical line. Watch this. So it's going to go 1, 2, and 3, right? On the x-axis. And if I put a line through there where it's only equal to 3 and it's not going to touch the y-axis, it winds up being a vertical line. So it's a little bit of irony when we see these individually graphed lines that are just a vertical or horizontal. Okay. When we graph using standard form, we're going to actually graph using intercepts. It winds up being pretty fast, okay, compared to if we actually use function form. So watch this. We're going to use intercepts to graph. X plus 2y equaling 6. Now, the question then becomes, what does this word intercept mean, right? Remember, think about when, like even with football, we hear the word interception, right? It's just, what happens is it means that the line of the pass is effectively cut off, right? So, and received by the defensive team. So, the idea is the same. It has to do with where these things are cut off, or where it's going to interact, or in this case, intersect. So watch this. So we're going to use intercepts here. Create our coordinate plane. Of course, we have the y and the x-axis. And here's how we graph using intercepts. First of all, we're going to cancel out each of these, okay? I think what I really like about these problems is that you can solve them with your thumb. So on your paper, you can take your thumb and you can effectively cover up each of these things. So the x-intercept, right, is where y is equal to 0. Well, think about this. If I were to go and make y equal to 0, 0 times anything is going to cancel it out. It's not going to exist. So watch this. You would take your thumb, cover up 2y, and you're just left with x equaling 6. So let's put our 2y back. We know x is equal to 6. That's our x-intercept. Our y-intercept is where x is going to be equal to 0, okay? In other words, where it's going to go through the y-axis, okay? So again, you use your thumb. You're going to cover up x, right? Because if it's 0, it's like 0 plus 2y. Well, let's solve that, okay? What's y going to be equal to? Well, of course, it's 3, right? That's a problem that we can do in our heads. So those are our two intercepts. X is 6 and y is 3. So we're going to go here onto the coordinate plane. X, 6, 1, 2, 3, 4, 5, 6. Now we're going to go onto the y-axis, y equal to 3. So up 3. 1, 2, 3. And I've got 2 points, right? One on the y-axis, one on the x-axis, and all I have to do is connect the dots. Now you see my line kind of sucks there, right? It's not very straight. So do your best. Use a straight edge if you'd like, but you don't have to, just as long as your line's not too wonky, I can live with it, right? And there it is. That's how we graph using intercepts. It's actually a pretty kind of fun and straightforward process. Let's do one more of these, just like this. Okay? So we're going to use intercepts to graph. And of course, we're going to use intercepts to graph when we have standard form, typically. And the reason why is because, again, we can do the problem with our thumb, right? It's going to be as straightforward as covering it up with our thumb. So we create our coordinate plane once we're done copying down this problem. Of course, I have my y and I have my x axes. And cover it up. Cover up x. Y is going to be equal to -3. Cover up y. X is going to be equal to -9. That's all we need. We have -3. We have -9. So let's graph them. -3 on the y-axis. And then -9 on the x-axis. I have my 2 points, and I can just connect the dots. So I've made these effectively a very quick arithmetic problem. Just use your finger. That's all. Again, if we're in function form or slope-intercept form, that's not going to be the desired method. But when we have something in standard form, which is just it's something that is done, then we're going to have to solve there. Okay? So let's do a little word problem here, something that you're going to see on your homework. You're going to the fair and have $16 to spend on rides and games. Ride tickets cost $4. And game tickets cost $2. The equation 4x plus 2y equals 16 models this situation. Where x is the number of ride tickets you buy, and y is the number of game tickets that you buy. So this is one of those situations where we can see standard form being utilized. Okay. We have two things here. We're going to have, say, graph the equation. And interpret the intercepts. And we're going to find 4 possible solutions. Because let's think about this. If we graph our function continuously, right? If we graph a line, it means that there's going to be fractional parts, right? And we know that that's not something that's possible. You can't use a fraction of a ticket. I mean, I guess you could try. You could tear it in half and try to sell the guy running the line on it, but I'm not sure that's really going to work. All right. First of all, I'm only going to draw the first quadrant here. Why would I only want to draw the first quadrant? Well, because I'm not going to have anything negative, right? It's impossible. I can't owe tickets. Okay? So, again, our situation, 4x plus 2y is equal to 16. Again, use your thumb. Okay? Let's cancel out y. Make it equal to 0. Put your thumb over that. It just says 4x equals 16. Well, that's a quick one for us, right? X is going to be equal to 4. Now let's do it the other way around. Cover up 4x. It's gone. Now we just have 2y equal to 16. So y, of course, is going to be equal to 8. It's a quick problem for you, right? Those are our intercepts, okay? So let's go ahead and graph those guys. 4 on the x-axis. Eight on the y-axis. I have my 2 lines, and I'm going to connect the dots. Okay, we can't have fractional tickets, right? And remember, X means ride tickets, and Y means game tickets, okay? So we have 2 quick ones that are very simple, right? When X is 4, Y is 0, so X again, 4, ride, and then 0 for game. We could do it the other way around. We could say the ride would be 0 tickets, and the game, the Y, right, would be 8 tickets. That's 2 of our scenarios. We need 2 more. We have to make sure that the input-output would also give us, and in this case, it would be 2 inputs, would give us some sort of whole number, okay? So let's look at another situation. How about here? How about 2? Looks like 4, right? That's going to be on the line. That means it's possible, okay? So again, ride would be 2. And then game would be 4. Let's make sure that it works. So ride is going to be 4 times 2 plus game, which is going to be 2 times 4. Let's see if that equals 16. 4 times 2 is 8. 2 times 4 is 8, which is 16. And 16 is equal to 16. So is that possible? Absolutely. So that one works. We need 4 solutions. Well, let's try to do another one. How about if we have 3 for game and 2 for ride. Let's see if that works. Or sorry, ride is x. So ride is 3 and game is 2. There we go. 4 times, remember ride is 3. And that's going to be 2 times game, which is 2, right? Ride is 3, game is 2, because ride is x, game is y. Let's see if that works. 4 times 3 is 12. 2 times 2 is 4. And 12 plus 4, of course, it's going to be 16. So therefore, 16 is equal to 16. This guy checks out. There's our 4 scenarios. Sweet. Are there more? Sure. I think there are more, right? Like, for example, ooh, I wonder if this one works. Looks like we could do ride being 1, 2, 3, 4, 5. Okay. And game is 2. Or sorry, game is 1. Wonder if that actually works. 5 times 4, ooh, that's not going to work, right? Because 5 times 4 already is going to be 20, and that's already bigger than 16. So that guy actually doesn't really work here, okay? So I think we found our 4 scenarios. Excellent. Okay, so that's all that we have for today. Your assignment is posted on Canvas. Good luck.